All right, guys, welcome back. Reshma Haber again, come from Wayne State University, continuing the series on logarithms, exponentials with Math 1800. I just want to go ahead and knock out two problems that I put on the last video that I told you guys to work out, because domain is not a new topic, but I gave you a new domain restriction that came with logarithms, and we discussed where it came from. So let's talk about domain of these two functions real quick, and I'm just going to do the first one, okay? So now, once again, what are your three restrictions? One, let me go up and see it. Denominators can't be equal to 0. Even roots, the radicand must be greater than or equal to 0. And finally, if you have a logarithm, this is the new one, the argument, the b part, must be strictly greater than 0. And we discussed why in the previous video. So I'd go tell you to look at that if you really want to see where it came from. All right, so now it comes down to a question, and let's just look at part A. How many restrictions do you have? Well, let's see. If I have a denominator cannot be equal to 0. So that means 2 minus square root of 6 minus x cannot be equal to 0. Yes, that's one problem that you should be okay with solving, so I'm going to go through and solve that in a second, but not now. Let's look at number 2. Number 2 is even roots. Do I have an even root in this problem? Yes. What is the even root? 6 minus x, and that thing must be greater than or equal to 0. Well, good news is it's not a linear, let's say this, it's linear. So you don't need a sign chart. Life is good. And don't forget, to solve a nonlinear inequality, you need a sign chart. And then finally, part 3 is do you have a logarithm? And yes, sometimes it could be no for this, but in this case it is not. So 2x plus 7 must be strictly greater than 0. Now, if you can solve on 3 of these and then marry them together, you're ready to rock and roll. So here we go. Square root of 6 minus x cannot be equal to positive 2 after it's all said and done, right? Subtract the 2 over, multiply by negative. How do I undo a square root? And yes, the answer that should come to mind is you square both sides, which gives you a 4, and then undoes the square root. And now, can we work through this? X cannot equal, what is this, 2? Right? Subtract 4 gives you negative 2, and multiply by negative gives you 2. Done. Okay? And then it makes perfect sense, because that would be the one that blows the denominator up. So we need to toss 2 out. All right, if we solve this guy, good news, no sign chart. X must be less than or equal to 6. That's easy. Easy solve. And here's one. X is greater than a negative 7 over 2. All right. Now we need to go through and marry each one of these together. So that means a domain of function that is in part A. Let's draw a picture to this, and I'm going to put this one in red. This one we'll do in yellow, and this one we'll do in magenta. Hey, what? The other ones are highlighters. Let's use a highlighter for this one. So then instead of red, we will use turquoise. I've been working on my colors. You see that? All right. So here's my number line. Here's the number, negative 7 over 2. So that means negative 7 over 2 says, I like this number and everything ahead of it, right? Greater than. Now, where is the number 6 at? The number 6 is here. Why? Because I said so. And then that tells me that I like every number, including the number 6 and previous. So you can see there's a clear overlap between negative 7 over 2 going forward and 6 going back. It's everything that's in between. Now, magenta man, where does 2 live? 2 lives somewhere in between here. I'm going to call it right here. I can't have that guy, so 2 says, oh, no, you don't. I know you like everybody, but you just can't have me because I'm like being allergic to peanuts. So this is a no bueno all the way through here, right? So, moral of the story, what is this going to look like when it's all said and done? So it'll look like something like this. Negative 7 over 2 and 6. I can have 6. I can't have 7 over 2, and I can't have 2. 7 over 2 said everything bigger. 6 said everything less than. Can't have 2. So this is my domain for part A. What is the U doing there? Oh, when you write a U, it goes there. Union 2 to 6. Why does my 6 looks like I'm going to write an S? I have no idea. So there's my domain. Easy, right? Easy peasy lemon squeezy. All right, so let's look at this guy. Part B. Okay. Once again, It's a domain question, so do you have a denominator? Obviously, I have a denominator. Denominator can't be equal to 0. That's part 1. So the entire denominator, which is log base 4 of x squared minus 9, this thing can't be equal to 0. Part 2. Do you have a even root? No. Thank God. Don't have to worry about it, right? And then finally, do we have a logarithm? Yeah, we do. So we have to worry about when b is greater than 0. So this thing must be strictly greater than 0. All right. So good news. This is where we start today's video. This one you should know how to solve with no problem, right? This is a nonlinear inequality which requires sign chart. So you'll have some work that looks like this, right? This is the function. Here is -3. Here is 3. You'll get something that looks like this. And you don't want your zeros, right? Because you want strictly greater than. So that means these are your answers. So that is the answer for this guy. I still need to marry it to the guys that we toss out from number 1, though. So here's the question of the day. How do we solve logarithms? Which brings us to today's video. And it's really not all that bad. I know people tend to look at this like it is a pain in the neck. It is probably the easiest thing to do because everything in mathematics is done with a purpose. Einstein, great quote. Even though people would like to conjecture that math is very, very weird, is that Einstein said math was invented or discovered to help explain natural phenomenon, okay, to make things easier. Okay, and I was listening to, I forget who it was, I think it was Les Brown, but Les Brown said that it is easier to think things are like God-given talent that is already existent, that it cannot be explained. It's easier to do that because it's too hard for us to understand it, rather than putting in the work, to understand it. Okay, and I guess that comes down to the fence of what side you're on. Like, do you put in the work or do you just fall apart? Okay, so how do we solve an exponential? Well, good news is, guys, this is not a hard problem. It's like anything else. We isolate for the log. And guess what we do once we isolate for the log? Then, because we know our laws of logarithms, we will exponentiate it, turning it back into a normal polynomial, and then we'll destroy it like we do everything else. Okay, so here we go. What do I mean by isolate for the log? You know this is -2? It's not a log. I'm going to add it over. So you get log base 4 of x squared minus 9 equals 2. All right, here we go. And I talked about this on the last 3 videos. There are 2 ways you can approach this. And you notice I'm talking about 2 ways because one is the baby way. One is the actual way. Actual way is way more applicable, guys. That's why I keep saying the actual way. All right, so, but they're both 100% valid. I'm talking crap about one because it doesn't have a whole lot of variety in it. So take it for what it is. So this is solving a exponential logarithm, and then we'll talk about solving exponentials in greater details later when we get to harder stuff, because this is like a layer, another layer that we can add on top of this. So you could use the definition. That's the baby way. The base is 4, the exponent is 2, it's equal to x squared minus 9. All right, can we solve this? Absolutely. 16 equals x squared minus 9. X squared equals 25. X equals plus or minus 5. Then it can't equal this. Remember, this is a domain problem, so we don't want any one of those. And you would go back and you would intersect it with this thing over here, and then finally get stuff. Okay. Actual way, log base 4 of x squared minus 9 and the number 2. We would use the law of logarithms to say that we would base 4 both sides. It makes good sense. These are equal, yeah? Black. Oh, that was right. It got me. All right, you guys will be okay. The 4 and the log base 4 undo each other, leaving you x squared minus 9, which equals 16. And then you get x squared equals 25. And then x cannot equal blah, 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 plus or minus 5. And then these are still the 2 numbers we need to throw out. That means throw them out. So your answer is negative infinity to negative 5 soft union negative 5 to 3. Negative 3 soft union 3 to 5 soft union 5 to infinity. Okay, so this is not really that hard, okay? It's just being able to manipulate exponentials and logs, okay? So you notice we're going to be solving both kinds of equations in this video. We'll be solving log equations, the ugly ones, and I notice I'll keep emphasizing to the definition, which is doable, right? But notice there's only one log in this problem. Okay, so let's just talk about solving logarithms in general when it's not that basic. Not that basic. And I always feel like people, this topic can be a real giant cluster of just disaster if you're not very careful with how things work. Yeah, yeah, I guess that's with everything, all right? So let's just talk about solving log equations in general. Okay, and this is a continuation. I think this is like section 4.4, 4.5, and I'm a big fan of just not using the definition of logarithms anymore and just base flooring everything. Okay, let me give you one. Okay, so here's an example of why the definition is a little obsolete and takes more time. Okay, and I'm going to do this both ways so you see it. I want you to solve for x. So here is log base 10, which is, obviously it's base 10 if they don't write it. X plus 1 equals log base 10 of 2. Now note, this is a problem that I got from the final exam of the previous course, but we're going to do it in an 1800 pre-calculus kind of a way. Okay, so let me tell you what the previous course was. Okay, so this is algebra. In algebra, all you had was that conversion definition, the baby way as I call it. Okay, so this is what they would tell you to do. Put all the logs on one side and then use your log properties to consolidate them together. So what does that mean? You would have to do all this work. Then you'll say, oh, you're multiplying two logs with the same base. That means you're adding two logs with the same base, which means you're multiplying the arguments. And then finally, the subtraction. So you log base x times x plus 1 means you're going to be dividing the two arguments equals 0. And they'll say, okay, guys, what's the base? The base is 10. You get 10 to the 0 power is this crap over here, right? Over 2, right? And then finally, they'll say this is 1, which equals x times x plus 1 over 2. Then you'd multiply the 2 finally, and you'll get this blob of crap. All right. Now, obviously, you guys can take it from here, but I'm a big fan of showing you guys why ways are more efficient than other ways. Okay. So now let's talk about the 1800 pre-calculus. I keep saying 1800 because I know I got watchers who are not at Wayne State watching this video. So this is pre-calculus kind of way. And this is where we use this property, that if we base a side with the same base of x, it undoes it. Okay, so watch this. Same problem, log base 10 of x plus log base 10 of x plus 1 equals log base 10 of 2. Yes, you still need to consolidate your logs, so that's still very important. You need to have all your logs on one side consolidated. But you notice I'm not going to subtract the other log over. What's the base here? It's 10, and this is the superiority of the 1800 way of doing things. I'm going to base 10 both sides. When I base 10 both sides, this undoes this guy, which leaves me x times x plus 1. This undoes this guy, which is just 2. Notice we are in the same place with half the work. Okay, this is the superiority. Okay, a lot of people say I can get the answers. Great, but good news is that you can get the answer. Bad news is that you don't have an infinite amount of time. If we had an infinite amount of time to do whatever we had to do in life, we would be good. Anybody could go and Google and search, and at that point in time, you wouldn't need anybody with degrees. You could just figure it out as you went along. This is not how life works, though, unfortunately. Now I'm going to, so the work comes down to this. X equals -2, x equals 1. All right, now once again, check your answers, because obviously with any problem that has domain restrictions like logs, it may not check out. So here we go. Plug in -2. Check this out. How the heck is that going to be negative? Remember, we talked about this. The arguments must be greater than 0 at all times. This is garbage. Gone. Plug in 1. Log base 10 of 1, that's 0. So that would be 0. Log base 10 of 1 plus 1 is 2. That's equal to the other side. Done. We are good. So the answer here is just 1. Easy. Solving logs is very, very easy with the new twists of 1800, which is very, very convenient. Okay, so this is stuff you've seen before. Now, I really want to tag that back to what we were doing when we were, so that was a log equation. Let's talk about an exponential equation. Here's a basic one. Oh, yeah. So you're probably saying, well, Resh, this is cool, right? I can just use the 1050 definition baby way. Once again, baby way. I know, I keep telling you guys this is baby way. So here's the baby way. Use the definition. The base is 2. So log base 2, the answer is 17. That equals x. That's the answer. Done, right? You're like, yay, we're done. Great. But good news is this is the baby way. Okay? Where you use the definition. Let's talk about the pre-calc way. Okay? So check this out. If you have an equation, and the reason why I'm stressing you guys out about this whole baby way and not baby way is, notice how we have one base here. The base is 2. You have yet to see a problem that looks like this, and you have to solve for x. So what the heck do we do when we have 2 different bases? And that's what we're going to talk about. So I want to talk about this baby problem with 3 other alternatives, or other alternatives you can choose. Notice the base is 2 here, right? So check this out. I could log base 2 like I did the previous one. So, and this is a cool thing. You guys already know with the equations, you could do whatever you want as long as you do it to both sides. So I'm going to log base 2 both sides. Here's 17. Here's 2 to the x. It undoes each other. I told myself I was going to switch colors, and I did not. Sorry, guys. This gives me 2 to the x. This is 17. This gives me x equals log base 2 of 17. Answer, same as that one, right? That was A. Let's look at another way. Let's say we didn't use 2. Let's say we had to use a different base. So let's say Resh was being tricky. He says, use anything but 2. Give me another number. You pick the number. Doesn't matter what it is. Pick it in your head. Actually, let's play a little magic trick. I'm going to try to read your mind now. Pick the number. Go. All right, cool. Seems like you chose the number 5. So let's use the number 5 as our base. So here's 2 to the x, and here's 17. I'm going to log base 5 both sides. Is it very, very good to use this? No, absolutely not. Why? Because obviously it doesn't go away all clean, and you have logs all over the place. So how is this helpful? Well, you guys remember your log properties, I hope. You guys remember this one? Remember, we're solving for x, right? So logging an exponential allows you to break into this argument. You guys remember this? Log base a of x to the y when the bases are different. Here the bases were the same. Here the bases are different. So we can parachute that out. This is not an equal sign. I don't know what it's doing there. Okay, gives you that, right? So check this out. X log base 5 of 2 equals log base 5 of 17. So good news. Check this out. This is just a number times x. This is just a number. I'm going to divide by this number. X equals log base 5 of 17 over log base 5 of 2. Now you're probably saying to yourself, Resh, why in the heck would I want to use base 5, right? Or are these the same? I guarantee you, if you put these in your calculator, you'll get the exact same answer. They are the same. Okay, so you're probably saying to yourself, why in the world would I want to do this? And because of this, and you're going to notice that I always do this, I will never use base 5. I will always use, and as a matter of fact, I get to a point where I don't even use base 2 anymore. I hate writing subscripts, and you'll notice most people in the world hate writing subscripts. So what we default is, universally, we natural log everything. Let's redo the same problem, except I'm going to do this. ln of this and ln of this. This gives you x ln of 2 equals ln of 17, which is x equals ln of 17 over ln of 2. Now, why is this more beneficial than this guy and this guy? I want you to put these into a calculator. We're going to do a little experiment. I hope my computer has a calculator on it. It should. Calculator. All right. How do we get the, is there a graphing calculator on here? Scientific is what I want, right? I think that's what I want. Programmer. Nope, that's not it. Hello. Data? Date? No. Oh boy. Standard. That's what I had before. I think I've already been here. What happens when you blow it up? Oh, I get my ln finally. That's what I was looking for, is the ln. So let's see if I can just expand this. You gonna give me an ln? Oh, thank you. I understand there's 0 there. Alright, so let's see if I can do this. Clear this out. Alright, so log base 2, and this is the point I'm trying to make. I'm sorry I was having malfunctions here. Log base 2. And this is kind of the problem with calculators. Unless you know something called the change of base formula, which I feel is the most useless piece of information in the world, but people think they find it very, very useful, you would have to use base 10 or natural log. Now, the base is the pain in the neck, because how do you write a subscript into a calculator? And that's the point, is that you couldn't really write base 5. And you couldn't really write base 2, even though this is 100% correct. If you wanted to compute it, this was the only default way you could do it, because it didn't have any issues unless you wrote base 10, which is why our calculators have straight up LOG in it. Okay, I always will ln everything because there's 2 less characters to write as opposed to 3 and then a subscript. It's just too much. Okay, so I want to do ln of 17 over ln of 2. So to calculate this number or this number, I really need to put this into a calculator. What happened? So here we go. 17 ln divided by 2 ln. That's what that answer is. Okay, negative 0.69314, right? Which that's what this ends up being, is 0.69314. I guarantee you, if you find some calculator that's really high powered or expensive that can change bases to base 2 and base 5, you'll note that these two are the exact same values. Okay, so that's the superiority of using LNs to compute things. Okay, guys, so I'm going to encourage you to always use your natural logs to help you compute stuff. And I'm always going to use that from now on. Okay, but you need to know what's going on. So, very, very important. So let me show you why this is superior. What if I said solve? Am I still on here? Still graphing? Yeah, we're still recording. I thought I was concerned. Let's say I said solve for what am I doing here? Solve for x. Duh. 2 to the x equals 5. X minus 2's. Yeah, I know, right? So here's the issue. If you use base 2, you can kill this base 2, but then the log base 2 over here is not going to kill the 5. You're still going to have to parachute that out if you log both sides. Remember, because we're solving an exponential. It's not a log equation. We're going to use logs to kill it. If it was a log equation, we would use exponentials to kill the log equation. Okay, so it's very important you understand the difference between the two. Okay, so here, log base 2 to the x. I could use base 2. I could use base 5, right? But I couldn't plug those into calculators. So if you notice, we do things so we can use technology for it. So what I'm going to do, and you'll notice this, is I'm going to ln everything. So here we go. I'm going to ln the right side and the left side. Good news. Now watch this. Be careful. I'm now going to parachute the exponents out. This would be x times. This would be x minus 2 times. Notice I put it in parentheses because there is multiple of them. Things inside the parentheses, that is. ln of 2. Now note, ln of 2 is just a number, so don't freak out. You're going to multiply and divide, add, subtract numbers. So be very, very careful. And this is ln of 5. Just a number. Now watch this. I need to solve for x. Welcome back to 1050 or whatever algebra course. We need to put all the things with x's on one side. Well, we need to break this parentheses through up. So I'm going to do that by doing this. Okay, so I get x times ln of 2 equals x times ln of 5 minus 2 ln of 5. Alrighty, so far so good. Now I'm going to subtract everything with x's onto one side. So x ln of 2 minus x ln of 5 equals negative 2 ln of 5. And then factor everything into one spot, ladies and gentlemen. Life is warm and fuzzy with a capital F. Fuzzy. And then divide. Notice x is now on one side. Life is good. And once I put the last pen stroke down, we are officially done, guys. That's it. Now, if you base 2 everything, you could plug this into a calculator with no issue. This is calculator ready. Let's say I would choose a base of 2 instead, which is valid. So if you did it on a quiz or exam, you would not be penalized, obviously. Just note that if you forget to write the correct base there, you will be absolutely penalized because you've changed the problem. This is what the same problem would look like. This gives you x equals, still got to parachute that out, 2 minus 2 log base 2 of 5. Still got to distribute it in. X equals x log, don't forget the bases, 2 of 5 minus 2 log base 2 of 5. Ew. Now, this is x equals, oh, sorry, I need to subtract this over, minus x log base 2 of 5 equals negative 2 log base 2 of 5. Why am I subtracting it over again? I want to isolate for the x value. This is 1 minus log base 2 of 5 equals minus 2 log base 2 of 5. And then finally divide by this crap. So another possible way of expressing the same dang on answer is by doing this. Now, we've already talked about you putting this into a calculator is impossible, virtually, unless you have a very expensive calculator or you know some technology that's going to be invented probably in the next couple of years that can do it for you. Okay, but this is all there is to it. Okay, no ifs, ands, or buts about it. This is all there is to it. How far in are we into this video? We are what? I don't know. How far in are we? 28 minutes in. Holy moly. So sorry, guys. We've gotten a little longer than I anticipated. All right. So, once again, this is Rush Mahaber getting ready to sign off. Again, if you're going to do anything, guys, always make sure that you experiment with multiple ways so you can see the differences in the two. Because those questions of why we don't do things is probably just as important of the questions of why we do things. We do things a certain way because the other ways are less efficient. But in order to understand the power of the way of doing the things that's more efficient, you got to actually go down the road of terribleness, of less efficiency. Okay? So once again, if you want to go someplace you've never been, guys, you have to do some things you've never done. So make yourself uncomfortable, keep pushing, and I'll see you on the next video. All right, Rush Mahaber signing off. Adios.